Welcome back to our website of DevTalks. We are still dealing with coordinate geometry. So we are moving to the second example. Example 2. Can say P, Q, and R are the points, and the points 5, -3, -1, 6, and 1, 8. Show that the triangle PQR is isosceles. So if we want to prove that it's an isosceles, what do you know about isosceles triangles? They're the one which have got two sides when they are equal, they have got the same lengths. So we want to prove this one using our idea of lengths. So how do you prove this one? Can we first have a sketch? This is our point, this is our triangle. Can say this is P, can say this is Q, this is R. Do we know point P? Point P is 5, -3. Do we know point Q? -1, 6. Do we know point R? Is 1, 8. So if we want to prove that it must have two equal sides equal, can say for isosceles triangle, two sides must be equal in lengths. So I want to start now by proving. I want now to get the length PQ. Want first get the length PQ, and we are going to use the format of getting root of x2 minus x1, the whole of it squared, plus y2 minus 1, the whole of it squared, which becomes root of, do we know x2 according to PQ? What is our x2? I can say -1 minus 5, the whole of it squared, plus, can say 6 minus 3, the whole of it squared. So we go ahead. This is -6, and -6 squared we are coming out with 36, plus this one becomes 9 squared, that is 81. 9 squared we are coming out with 81. So when you try to add 36 plus 81, we are coming out with that is 7, that is 117. We are coming out with 117 units as our lengths of PQ. So after coming out with the lengths PQ, also go to lengths QR. Can we go to lengths QR? How do we get lengths QR? Still, we are going to use the same. Can say x1 minus x2, the whole of it squared, plus y1 minus y2, the whole of it squared, which becomes with, we are looking at QR, we are going to have -1 minus 1 squared, plus we have got 6 minus 8, the whole of it squared, which becomes -1 minus 1. What are you getting? You're getting -2. And -2 squared, you're getting a 4, plus 6 minus 8, that is -2 squared, we're also getting a 4. So what I'm getting, you're getting root of 8, which is the same as, if you try to reduce it, which is the same as 2 root 2 units. So also now, after coming out, we are also coming out lengths of PR. How do we get the lengths of PR? Still, root of x1 minus x2 the whole of it squared plus y1 minus y2 the whole of it squared. So what are we getting? We are getting root of, what is x1 is already 5 minus 1 squared plus negative 3, we are getting negative 3 minus 8 the whole of it squared. So can we go ahead? We are getting root of, we are having 5 minus 1, 5 minus 1, we are getting a 6, and 6 squared, we are coming out with 36 plus negative 3 minus 8, we are coming out with negative 11, we are getting 121. So what are we coming out with? We are coming out with a root of 4. We are coming out with the length of 181. We are coming out with 157 units. Now, are the two lengths equal? If they find that they are not equal, then you conclude. But if you find that the lengths are equal, then you are free to can say, since the two lengths are not equal, then the triangle is not isosceles. So it's all about dealing with lengths, and when you're dealing with lengths, get each and every particular unit. Still, we are moving to the another part of it. Which would mark at the part of lengths as we proceed to another part. Can call it example 3. Can say find the lengths. We can say find the distance. Find the distance between the points. Can say with part A 2, 1 and 5, 5. Part B 3, negative 2 and 4 and 3, 7. Part C can say negative 2, negative 3 and negative 5, 4. Let's try to look at the solution on these ones. So we are still getting the distance, and when they said the distance of magnitude, all of them, they are meaning one thing. So can we start with part A? We are given the 2 points. I've got my first point, I can call it A, 2, 1, and point B, I can call it 5, 5. So what we're going to do is this. Can we get lengths AB? AB, you can say this is x1, y1, x2, y2. How do we get AB? Still root of x2 minus x1 squared plus y2 minus y1 squared, which becomes root of, what is x2 is 5 minus 2 the whole of it squared plus, again, 5 minus 1 the whole of it squared. So we go ahead. What is 5 minus 2? We are getting a 3, and the 3 squared we are coming out is a 9 plus 5 minus 1, we are getting a 4, and the 4 squared we are getting a 16. 9 plus a 16, we are getting root of 25. And what is the square root of 25? Is at 5 units. So you can see that the length from here, the distance from here to here, is counted as 5 units. So We are still moving on to part bar. Still the same, I've got the 2 points, 3 -2 and 3 7. So if I have this line of mine as P given as 3 -2 and I've got Q as 3 7. So how do we get that length? We want to know the distance from here to there. Same story, we can say PQ root of x1 minus x2 squared plus y1 minus y2, the whole of it squared, which becomes root of, what is our x1? Is already 3 minus 3 squared plus -2 minus 7 squared. So what is 3 minus 3? It is 0, and 0 squared we are getting a 0, plus -2 minus 2 we are getting -9, and -9 we are getting 81, which remains as 9 units. So we are moving to part cha, the same story. If we have got this point and we have got point A as -2, -3, and this is B as -5, 4. So we can still do the same as AB substituting. We are going to substitute in our formula. What is our x1? Is already -2, minus becomes a +5, the whole of it squared, plus this is -3 minus 4, the whole of it squared. So which is root of -2 plus that is 3, and 3 squared, you're getting a 9, plus this minus that is 7, and 7 squared, that is 49. So when you add, we are coming out to the root of 58, and that one will be the units. So we have tried to discover much on those examples, and that's what marks to the end of the lengths. So we're going to move on to the next step in the next example, in the next video.